Hello students, welcome to Physics Bouquet. Today's topic is black body radiation. We will discuss about black body radiation. In previous video, we have already discussed what is thermal radiation and some of its properties which resemble that of the light. And today we will discuss black body radiation. Before thoroughly discussing about black body radiation, let me tell one thing. The color of an object, the color of an object is due to the color it reflects. For example, एक पेपर व्हाइट दिखता है, मतलब it is not observing any of the radiations, it is reflecting all the radiations, and we know white is the mixture of all colors. So since it reflects all the colors, therefore it appears white. एक रेड रोज है, ये क्यों रेड दिखाई देता है? Because it is observing all the visible colors except red. It is reflecting red color and rest of the colors are observed. That's why it appears red. Similarly, if a body is able to observe all the colors and does not reflect any of the colors, then that appears black, because it is not reflecting any color, therefore it appears black, and such a body is called a black body. So black body is that body which is able to absorb all the wavelengths falling upon it. So it observes all the wavelengths, whichever wavelength falls upon it, and therefore it appears black, and it is called a black body. Now I am saying about three terms, that is absorptive power, reflecting power, and transmitting power. Transmitting power. Absorptive power, suppose this is a body and the heat energy incident upon it, total energy incident upon it is I. I is the total energy incident upon it, and it is able to absorb, suppose, A amount of energy. So A amount of energy is absorbed and I amount of energy is incident. Then this A by I is known as absorptive power, and it is generally denoted by the letter A. Similarly, reflecting power means it is denoted by R. Reflecting power is energy reflected divided by energy incident. and transmitting power is denoted by the letter T. It is equal to amount of energy transmitted by an amount of energy incident. And if we add all these three, A plus R plus T, then we have what? A by I plus R by I plus T by I. Then we have A plus R plus T by I. But this is energy observed, reflected and transmitted. While saying about the properties of thermal radiation, I have already said, whenever certain radiation falls upon a body, it is either observed or reflected. It is observed, some amount is observed, some amount is reflected and some amount is transmitted. So this total is A plus R plus T is total energy. So total energy by total energy, it gives 1. So our A plus R plus T is equal to 1. That means absorptive power plus reflecting power plus transmitting power. That means sum of absorptive power, reflecting power and transmitting power is 1 unit. Now come to the black body. For a black body, this reflecting power, transmitting power, both of them are 0 and this absorptive power is 1. So absorptive power of a perfect black body is 1. It is able to absorb all the energy incident upon it. And the nature of the substance, whatever it may be, but the temperature of that substance determines the black body. So black body is temperature dependent. It doesn't depend on the nature of the surface. Then one more thing I will tell, there is no 100% perfect black body. There are black bodies which are 97% to 98% observer. They can observe 97% or 98% of the total energy. And for practical purposes, lamp black and platinum